Yes, Assalamu alaikum. I'm Mr. Muhammad Abdurrahim, math lecturer, IT department, Shinas College of Technology. In this video lecture, we will learn what is a linear differential equation and how to find the general solution for that. So, what is the general form of a linear differential equation in y? First, I'm writing the general form d by dx plus p of x equals to q of x. So the general form of a linear differential equation in the variable y, that y is important. Y here I am taking y and multiplied by y. So if dy, this is dy and y are there on left hand side of equal like this, then we say this is a linear differential equation in y. If you see this is equal, the right hand side is not having any function of y, or the term y is not here, only function of x, right hand side. Whereas on left hand side of equal, we have dy and y. That is must for a linear differential equation in y. And here the coefficient al-muamil of dy by dx is 1, fun. Should not have anything here. If you have anything, then we need to divide to bring that given differential equation into the standard form. So the prerequisites which we know, which are required to understand, to study these topics are: number one, we need to have the knowledge of integration, and a rule from logarithms, that is e power ln x equals to x power m. It becomes this x power m like this. This rule we need. These two are the prerequisites. So let us see how to find the general solution for this differential equation in y, linear differential equation in y. First we find the integrating factor, that is e power integral p dx. P is a function of x and it is the coefficient of y, as I told, p. From here we collect p, and the general solution gs is y multiplied by if. This y, because this is a linear differential equation in y, here dy and y are there. If here dz and z are there, then here we will take that z. If here dt and t are there, we take here t. Integral q means this right hand side function multiplied by if plus c. This if is the integrating factor, which is for which this is the formula rule to find. So this is masala problem question number 1, and as you see, find the general solution of this differential equation. Yes, if you compare this with the standard form, yes, dy by dx, yes, it is dy by dx. Here 1 should be there, here yes, 1, nothing is there, and y, dy and y must be on left hand side of equal, okay, dy and y. On right hand side, nothing, no function of y should be there, yes, no y is there, only x, this is q of x. Yes, now we can start solving this differential equation with the rule. So this is in standard form. So I am starting to solve this differential equation. The first I will compare with the standard form. The standard form, let me write once, dy dx plus p of x multiplied by y equals to q of x. Yes, so p of x is here the coefficient of y. So p here is 1 over x, and q the function of x on right hand side, that is clearly here 3x. So first I need to find the integrating factor with this rule. I have e power integral p dx, e power integral p is here 1 over x, e power ln x, that is x. Next, the general solution, this is dy and y are there, so this is the rule, yif equals to integral qif plus c. So y multiplied by if equals to integral qif plus c. If is x, integral q, that is here 3x, right, 3x. If is we got as x. This is a function of x, so naturally dx follows because integration. And the last steps, yx, 3 constant, right, integral outside, x multiplied by x, bases equal, into multiplication, add powers, 1 plus 1 is 2, dx plus c, yx equals to 3, integral x power n dx, the standard rule, x power n plus 1 by n plus 1, if n is not minus 1. Yes, n is 2 here, not minus 1. So x power 2 plus 1, 3, divide 3 plus c. 3 of course cancel, y equals to x cube, divide x, this x I am dividing, c over x. So final step, x square plus c over x, where c is arbitrary constant. So this is the way of finding the solution for this differential equation, which is linear in y. So this is the second question. Solve the differential equation x divided by dx minus 2y equals to x power 3. Find the general solution, or solve means same question. So this is the given differential equation. As we see, equal to is here, right hand side, there is no y, it's okay like this, q of x, there is no y or function of y. But left hand side, x dy by dx minus 2y, yes, dy and y must be on left hand side of the equal. Yes, on left hand side dy and y are there. But if we see the coefficient of dy by dx, it must be 1, but whereas it is x. So first we need to remove this x. For that, divide the whole differential equation with x. X divide x is 1 here, so I did not wrote. Minus 2 divide x, x cube divide x. So all the terms we need to divide with this x. So to make this as 1. So now the coefficient of dy by dx is 1, it's okay. Minus 2 over x, x power 2. So on comparison with the standard form of a linear differential equation in y, we get p as the coefficient of y here minus 2 over x, not plus 2 over x, with minus. With the sign we need to take minus 2 over x is p. Q is right hand side, that is x power 2. First we need to find integrating factor, as we discussed earlier. If equals to the rule e power integral p dx, e power integral p is minus 2 over x dx, e power minus 2 outside because being constant, integral 1 over x dx, standard rule ln x. And this we discussed that the standard formula from logarithms, e power m ln x, x power m, so x power minus 2. So the general solution is y if equals to integral q multiplied by if plus c. Y we write y same. If we got if as x power minus 2, so x power minus 2 integral q, function on right hand side, here it is x square, so I wrote x square for q. For if, we get as x power minus 2, so x power minus 2 dx plus c This is a function of x, so dx follows naturally. So bases are equal, and multiplication, so add powers, 2 plus minus 2 cancel like this. So the next step will be the integration again. So the last step, y power x power 2 integral x power 0, that is integral dx, because this is 1, y over x square integral dx, integral derivative cancel, we know from integration. And if we take y cross multiply with x square here and here, x multiply x square x power 3 plus cx square, where again c is an arbitrary constant. So like this we solve this second differential equation. So this is the third question which we are discussing today for linear differential equation in y. As we see, dy and y are on left hand side, and on right hand side no function of y or y term is there, it's okay. But here this cosine square x is the extra thing which should not be there, because the standard form dy by dx plus p of x into y equals to q of x. The coefficient of y must be 1, but here cosine square x is there. So let us divide the whole differential equation throughout with cosine square x dx. Then the result will be dy by dx, cosine square x and cosine square x same, so cancelled. So y divide cosine square x, and also tan x divide cosine square x. So dy by dx plus y over cosine square x. From trigonometry, from the course pure math, it is there that 1 over cosine x is secant x. If you take cosine square x, then it becomes secant square x. So 1 over cosine square x we can write as secant square x multiplied by y as it is. 1 over cosine square x, again secant square x tan x. So this is, it's okay, this is exactly in the standard form of a linear differential equation in y, like this. So on comparison, p, coefficient of y is p, this is p, so p is secant square x, and q, the function of x on right hand side, the whole is q. So I wrote here secant square x multiplied by tan x. Next, as we studied, we need to find if. If will be into e power integral p dx. This is the rule which we need to remember. E power integral p is secant square x dx. So standard, this is a standard integral. E power integral secant square x is tan x. Next one is general solution. Since this is linear in y, yes, y if integral qif plus c. This is the rule for the differential equation. Later we go with y same, and if already we found as e power tan x. Yes, let us write e power tan x integral q is here. If you can see here, q is secant square x into tan x. So I wrote here secant square x into tan x. And if, we found if, and the result is e power tan x. So e power tan x dx follows naturally plus c. The y e power tan x as it is. So this is the integration which we need to do now. And we know this integration we can do with only the way of integration by substitution method. Substitution method we use when we found that in integral a function is there and its derivative is also there. If you see, if you take tan x, and the derivative of tan x, d by dx of tan x is secant square x. So if we let this tan x as some t, differentiate on both sides, then tan x derivative will be secant square x dx by the standard formula, and derivative of t dt. So here it's very clear that secant square x dx equals dt. If you want to write dx, it's okay, dt over secant square x. So this integration, how it changes? Write secant square x as it is, but tan x and tan x, we put that tan x as a t. So here and here we can put this, we can replace tan x with the t. So t e power t, and dx already we found, dx same dx here. If you see, dx equals to dt over secant square x. So that these two same, so cancelled, plus c. So integral t e power t dt plus c y e power tan x. We follow this same, no change in on left hand side always. So integral t e power t dt, this is a standard integral also. We can remember the for answer is t minus 1 e power t. So t minus 1 e power t, or we can go with the rule of by parts, or we can go with the rule. So this is the integration of product of two functions. So we need to follow ILATE, I for inverse trigonometric, L for logarithmic. There is no logarithmic here. A algebraic, yes, T is algebraic. So this is the first function because it is algebraic, and e power t is exponential e. This is exponential e. So a comes first here. So we take t as first function here, and e power t here. Let us differentiate this. This is a procedure for the shortcut of integration by parts. Integration by parts. So derivative of t is 1, derivative of 1 is 0, constant derivative 0. T differentiate, later stop anyway. Next, the second function e power t I took here, and integrate, integral e power t is e power t. Again integration e power t, because this is 0, after that we won't do stop. Next we take plus minus plus and we cross multiply like this. We leave this and we go like this diagonally. So t multiplied by e power t with the sign plus, this is the first term. Next the minus, alternate plus minus we take always minus. The 1 multiply e power t is e power t. Next plus 0 multiply by anything is 0, so we don't want. So plus c. So y e power tan x, and we can take this e power t as common also, t minus 1 e power t plus c. And if you see here, this is y e power tan x. T is actually a new thing, t is actually tan x. So for t and t we need to write this tan x. So t is tan x, so let us resubstitute e power tan x plus c, where c is arbitrary constant, where c is arbitrary constant. At least up to this we need to do. So if you can divide with e power tan x throughout, then it is better. Of course you can stop here also. So this is homework for you. The homework is I'm giving 3 problems. Solve the following differential equations: x dy by dx minus 3y equals to x power 4, x dy by dx minus 4y equals to x power 6 e power x, dr by d theta plus r tan theta equal to cosine theta. Here dr and dr and r are on left hand side. So this last differential equation, it is linear in r. So integrating factor e power integral p d theta. Or if you are getting confusion, you can replace y with r with y and theta with x. Then it becomes like this, and cosine x, and then you can proceed with linear in y. So these are the three as homework. So see the review of for this topic. uh, we studied what is linear differential equation. So linear differential equation in y, the standard form is dy by dx plus p of x over y equals to p of x. Dy and y must be on left hand side of the equal, and on right hand side no y term or function of y must be there, not allowed. Then we write if as e power integral p dx, where p is the coefficient of y on left hand side of the equation. And the general solution will be, as it is linear in y, we write y is strictly linear, y if equals to integral q if plus c. We need this rule. E power m ln x is x power m always from logarithms, and we need the knowledge of integration. And we solve these three questions as you see. And these three are homework.